Hello, today we're doing a follow-on video from the analysis video we did a few days ago. I'm going to run up multi-tool and I've got another simulation file that I want to show you and we can work with. So here's the analysis mode. I'm going to load a demo 3, which is another simulation file. Now I just want to show you a few extra features and maybe talk about something we haven't mentioned before as well if I can. So here we've got 3 asynchronous events. Now in real life this is a simulation file, as I like to say, but in real life you wouldn't come across this kind of response. You may in some more advanced or complex responses, but for the benefit of this video it's unlikely you'd see something like this. I just want to demonstrate how software can deal with it. So we've effectively got 1, 2, 3. So is it a single, double, is it a treble? Well, in actual fact it's all the same thing. And to have a look at where they occur, if you hold the left control key and press the left mouse button, the nodal diameter grid will shift to where you click. So if I click there, it shifts to it. If I click there, it shifts to it. What you can see, if I demonstrate on the bottom 2 alone, if I click on the center peak, which is about there, with the left mouse, with the control key down, they're the same thing. Okay, so what that really means is that it's the same event, it just happens to be on multiple nodal diameters. Now usually an event or a response will move from one diameter to another, but there are times when you can see a couple of nodal diameter lines being lit up at the same time. So just to prove that, I'm going to click on that and see what we get. And we've got 506 Hertz, ND5. I'm going to click on that, and we've got again 505 Hertz, ND minus 3. I'm going to click on that, and we've now got 506 Hertz again, ND minus 4. So it's all the same thing. Okay, but at first glance you might think there was multiple things happening when in fact there isn't. And the way to work out whether anything asynchronous is actually the same vent reflected on another nodal diameter line is to just move the grid, and if they're all coincident it's the same thing. It's just been reflected up or down. Okay, so I'm going to clear that and I'm going to clear the results. Okay, and I'm going to load a template. I've got a template prepared. Okay, and here I've got 2 mode lines. I'll just turn on the mode numbers so you can see them. Okay, I've also tweaked the ranges, so I've gone from 3000 to 8000. Okay, and 1000 on the y-axis. Engine order 3 lit up. Right, I will clear that again. Right, because that was stored in the template. Right, so again, click, click. You can see it's there. Click, click, just to reinforce it. Okay, there we go. So what I want to do is I want to pull up the analysis areas, and I'm going to show you that we've got this set up for a double. We've got a 3 engine order here, and we've got a mode here. Okay, I'm just going to extend that so you can see EO3 as I did in the previous video, but area 2 on mode 2, which is mode 2, area 2. If I click area 1, that one lights up. Click area 2, that one lights up. Okay, that is set as a mode analysis, so you get what it finds. So I'm going to click on Analyze, and it's going to do an analysis. Okay, that analysis is complete. I'm going to go to the result files, and that's the one we've just done. 1753, yeah, double click on it. Okay, and that's pretty much what we saw yesterday. Nice response. Very low uncertainty, and yes, it's a simulation. Okay, so lovely. But what I wanted to show you was, I'm now going to go back to the analysis area, and I'm going to change the mode from a double to a single. Okay, and I'm going to run the analysis again. So what I've done this time is I've said it's not a double. I want you to just analyze this on its own, and I don't want you to look at anything to do with that engine order down there. And that's done. Obviously quicker because it's a single analysis. So in the results, this is the one we've just done, 1754. Yep. Wow. Looks remarkably the same as the first one. And if we look down here on the bottom right hand side, it's identical. So what does that mean? Well, what it means in reality is, as you probably could have guessed from this display up here, there is no third engine order energy anywhere in this file. So we've incorrectly assumed that there was a third engine order, and we've said, can you analyze this? And can you analyze it against a 3 engine order? But the software's clever enough to figure out that there's no contribution from a third engine order, and so you end up with the right answer whether you do that as a single or whether you do that as a double. This does allow, if your Campbell said there was some energy there, for instance, you to not worry too much about the response, and there may be some energy there, there may be not. As I showed yesterday, if there's energy in the response that you haven't accounted for, then your confidence, which is the green line, will dip, and that's what we saw yesterday. Okay, so one more thing I wanted to show you was, if I wanted to use these files, what's the quickest way to get to them? I'm not sure I pointed out yesterday, but File, Open Current Configuration takes you straight to the files, and these are the files we've created just now. Okay, so I'll close that. So I think that's about it, just a short video really. Oh no, sorry, one more thing I wanted to show you, or just to explain to you was that when it comes to analysis areas, in fact I will go back to demo 2, but I won't do an analysis. I will just show you. Put speed back on so we can remember what we're doing. Analysis 2. When I did this yesterday, it just so happens that these were coincident. Now, if they're not coincident, it's perfectly fine to do that and offset them, and it will know, as I've just shown you on the other analysis, that if there's no contribution from this, it won't matter, but if there is a contribution, it will take it into account. So you can have them offset, you can have one overlapping the other, and vice versa, and the software will work out where the contribution, if any, is and take it into account. Okay, so before I sign off, there's just one last thing, or two last things I want to go over again. I've had some feedback and I just want to cover. First of all, I've covered in one of the earlier videos any analysis template in the data folder will pop up in the list with this little mouse symbol appears. If you've got a common template, again, in a common template directory, this is available. This will be shown in green, and you can have as many templates as you like. Okay, you pick the one you want from the list. That's just the same. It's found those three and it's put them in a list just to make life easier. Okay, and the other thing I wanted to show you was go back to the response. Okay, so uncertainty, speed. I just like to show it like this for ease of use. So, as you saw when it popped up, it briefly fades in, shift key. So left shift key, move the mouse, up and down makes no difference, but left and right gives you a real-time plot, or a real-time, track of the plot. So you can see amplitude, frequency, uncertainty, quality, speed, and the engine order. Okay. And if I go back to there, you can see, if you look at the bottom of that, it says analysis fit engine order. So in case you were wondering why it says EO3 all the way through, I'm looking at the engine order crossing and not the mode crossing. But I just wanted to show you that if you want point information, just hold the left shift, move the mouse, and it pops up. Okay, and just to clarify, that also works on this display here. As you can see, blade 7, 8, 9, you've got the amplitude, frequency, engine order, uncertainty, and speed. Okay, if you want to change the blade while you've got the viewing window open, shift click to change the active blade. Okay, and I covered that in an earlier video, but I just wanted to go over it again. If I just load that one, that's the modal fit. Show you again, same information. Okay, and the same down here. Right, I think that's a quick recap and we're good to go.